This is problem 3 on practice exam 7 of chapter 1 in the book Problem Solving with Differential and Integral Calculus. This is a study of fledged bald eagles. The only eagles that were counted were the ones that actually fledged. A lot of them don't make it. Those weren't counted in this study. So all 1,000 eagles here in this graph were fledged. So we plot when they fledged. So it's rare that an eagle fledges as early as 8 weeks, and it's rare that an eagle hasn't fledged by 14 weeks. Most of them fledge around 11 weeks. This is similar to a lot of biological processes, like when a toddler becomes potty trained, the age of a humpback whale, when its mother stops giving it milk, things like that. So part A, draw a tangent line at 10 weeks and estimate how many of the 1,000 left on the day of their 10-week birthday. And part B asked us to do the same thing at 11 weeks. Pretty straightforward. So let's start by labeling a point. We're doing 10 weeks right there. We're going to draw a slope, tangent line at that point to get the slope. The slope of this line is the number per time that fledged, number per time. So the rise goes from 0 to 920, something like that. And the run goes from 9.4 to 14, which is 4.6. So the rise is 920 eagles, and the run is 4.6 weeks. Divide those two to get the ratio, the rate. The rate is 200 eagles per week at 10 weeks. And you can't say that 200 eagles will leave in a week, because that rate is only good at 10 weeks, not good at 11 weeks. In one day, we can make an approximation. 200 eagles per week is about 29 eagles per day. So one day, about 29 eagles left. About 29 of the 1,000 eagles fledged on the day of their 10-week birthday. Now we got to do part B. It's the same thing for 11-week birthday. So we start by labeling a point and then drawing a good tangent line. The rise it's the whole graph. It's 1,000 eagles. And the run is 2 weeks, 10 weeks to 12 weeks. Slope, 1,000 eagles in 2 weeks, which is 500 eagles per week. To get how many left on the birthday of their 11th day, we have to get 500 eagles per week. 1 week and 7 days, 1/7 of that, so it's about 71 eagles left on the day of their 11th birthday. That's the answer to part B, and we're done with this problem as far as what's assigned. We're not asked to derive the difference equation, but we're going to do it here. It's probably a good idea to just watch, see how long it takes, to see what's involved. And if you're interested in understanding fundamental calculus and taking a derivative from first principles without following some rules that you don't understand, you might try to follow along as well. So here's the normal equation. And equations like this, when they're going to get messy, we don't want to carry around all these units, but just a bunch of baggage. We want to put on our math hat and only do math. We know that exponents can't have units. So we know that when you say t minus 11, the t has to be in weeks. You can't put a t in days in there. It's got to be weeks. And then you divide by weeks, so the exponent is a pure number. You can't have an exponent that has units. But we're going to leave out the units. We're going to understand that we have to put the units back in there. And we're going to drop the 1,000 eagles term. So that f, you're not going to like the t minus 11, because what units do you put in for t? Is it months? Is it, the 11 weeks has units. We have to remember that the t has to be in weeks. So we're just going to put on our math hats and do the algebra. We're going to take off that 1,000 eagles, but we have to remember to put it back in later. So now f just looks like that, and we can do math more easily with that. So there's the difference equation. We're going to change t by delta t, and the fledging rate is going to change by Number of fledged is going to change by delta F. And you have to understand how exponents work. E to the 6th is E cubed times E cubed, right? So we can write it like this. We can separate those two terms, have two exponentials here. Now this delta t is small. If delta t is small, we can write e to the x as 1 plus x. And you have to know infinite series. And you can test it with your calculator. E to the 0.0001 is about 1.0001. So e to the x when x is small is about 1 plus x. So e to the 2 delta t, and that actually is e to the 2 delta t divided by weeks. All right, so that's what it is with the units. And we could leave out the units temporarily, which is this, but you have to understand that this is a pure number, but this is 2 delta t divided by weeks. So now we have this expression, substituting in the limit for small delta t. And we can distribute that, 1 plus 2 delta t, and we get this. We have to solve for delta f over delta t. Subtract f from both sides. Remember what f was? That's what f was. So we're going to subtract that from both sides, and we need a common denominator. And it's going to get ugly. A lot uglier than this, believe it or not. Viewer discretion is advised. We're going to need the whole page. So I need a common denominator, and there's a common denominator, and we're going to multiply out the numerator. We can multiply that out. We're just going to say, I hope something works here. And a lot of terms cancel. We have this term in square brackets minus that term in square brackets. These terms cancel. These terms cancel, and these terms cancel. So the only thing left in the top is that 2 delta t, e to the 2 quantity t minus 11. So now we have this. There it is again. We could ignore the delta t in the numerator, in the denominator, right here. We have some terms that are non-infinitesimal. 1 plus this, but then there's an infinitesimal term, and we're adding it. So we can totally ignore this term here. So now we have this. This term here is the same as that when you get rid of the delta t. To get the slope, we just divide it by delta t, because it's delta f over delta t. That's the slope. So this is the slope at time t. Here's the time t right here. There's the time t. This is the slope at t. If we plug in any t, we should be able to get the slope. So we can plug in 10 weeks, we can plug in 11 weeks, and calculate the slope. Remember, we had that 1,000 eagles, so we got to put that back in too. And we put all the units back in. So parts A and B of this problem were the slope for 10 and 11 weeks, and we can substitute this in. So 10 weeks minus 11 weeks, that's minus 1. So we have e to the minus 2, 1 over e squared, and then times 2,000 in the top. And we can calculate it, 201, which is about what we got. If you plug in the numbers there, you get 201 eagles per week. We estimated the slope 200, and that's pretty good. We're happy with that. At 11 weeks, we get e to the 0, because we get 11 minus 11. E to the 0 is 1. So this is 1,000 times 2, which is 2,000. We have 1 plus 1 squared. That's 2 squared is 4. 2,000 divided by 4. 500 eagles per week, and that's what we got. Boom.